Okay. Let's continue, people. Last class we stopped at what were nodes. So nodes were, people, region in space where the probability to find an electron is 0. Now वही concept को आगे लेके जाके what we have to do is we have to plot something called as radial probability density curves. I repeat, what we have to plot is radial probability density curves. Okay. थोड़ा सा let's recollect what we've done in the previous lectures. Can someone tell me what is psi? Excellent. Wave function, or you can call it amplitude of the wave. What is Acha, and psi has two parts. Anyone remembers what were the two parts? There is a radial part of the wave function, and there's one more part. There is an angular part. Okay. Now, from that we're going to plot only radial part. The angular plots are not there in syllabus for us. I repeat, we're going to plot only the radial part of the wave function. Second, what was psi square? Probability density. Now we're going to add something to this. 4 pi r square psi square. I'll explain where did this part come from. 4 pi r square. This is called as radial probability density function. Okay. Where did this 4 pi r square come from? Just give me 5 minutes. We next part हम करने वाले हैं. चलो. So, let's say, people, I have center में यहाँ पे there is a nucleus. ठीक है. This is some shell. ये जो white वाला border है ना, people, that is some shell. What we have done is we have made एक छोटा सा inner shell. Let the radius be r and the thickness of the inner shell is written as dr. What we are trying to find in the radial probability density function is the probability to find the electron somewhere within that thinner shell. I repeat, एक हमारे पास shell of radius r. We are trying to find that where the electron is present within that thinner shell. Did you people get that? यहाँ तक? So it is something like this. Remember, every dot over here represents the possibility to find the electron. So what is that particular probability? वो हमने यहाँ पे लिखा है. 4 pi r square and psi square. Did you people get that? Chalo. So, can someone tell me what is the volume of a sphere? Formula क्या लिखते हैं हम for volume of sphere? Four upon 3 pi r cube. ठीक है? So this is the volume of that bahar wala sphere. What exactly is dr? What does dr stand for? I repeat, it is the thickness of the inner shell. And remember, this is very, very small. The thickness is, we've already assumed it to be very small. Okay, dr ka value is very small, almost tending towards 0. If this is r and this is dr, can someone tell me what will be the radius of the inner shell? How much will this be? Can I say this is r minus dr with me? So I want to know what is the volume of the shell or volume of the inner shell. How will I do that?
Volume of outer shell minus volume of inner shell.
Volume of outer shell minus the volume of inner shell. Can someone tell me what will be the volume of the outer shell?
4/3 pi r cube.
And what is the volume of the inner shell?
4/3 pi r minus dr.
4 upon 3 pi r minus dr the whole cube. Eventually when we solve this, हमें value मिलता है 4 pi r square. That is what we are trying to find. No one is expecting you to know ये सब derivation, but if you're trying to plot something, तो हमें पता होना चाहिए कि where did this probability density function के लिए where this 4 pi r square came from. यहाँ तक with me? चल, अभी हमको इसे plot करना है. Now what I have on the board is the 1s subshell. Can someone tell me, are there any nodes present in the 1s subshell? ढूंढ के देखते. What was the formula for radial node? So radial node was n minus l minus 1. n का value क्या है people for 1s? 1. s का value is? So this is, are there any nodes present? No. Now, what you have on the x-axis is r. R is radius, or you can say this is the distance from the nucleus. What you have on the y-axis, सबसे पहले is psi, or you can also write this as r. R stands for radial part of the wave function. NCERT में R लिखा है. Psi भी लिख सकते, R भी लिख सकते. If you just write psi, you should know that it's radial part of the wave function. It's not the angular part of the wave function. So we are plotting R versus psi. हमने subshell बनाया था last class, और उसके नीचे एक point लिखा था. Where is the probability to find the electron? It is near the nucleus. The probability to find the electron in the S subshell was near the nucleus, which means that, see, this is the nucleus. Where will be the highest possibility to find the electron? It will be near the nucleus. It will not be on the nucleus, say inside the nucleus. It will be near the nucleus. Hence the plot starts somewhere from here. So when you are very close to the nucleus, the probability to find the electron is maximum. As you go away from the nucleus, क्या होने लगा? The probability to find the electron starts decreasing. Do you people get that? कुछ याद है? Last class ही किया था वो. As you start moving, the probability to find the electron क्या होने लगा? Decrease होने लगा. The plot would look something like this. It will not touch the axis. Huh? It won't touch the axis. It's an exponential plot. Exponential plot क्यों भी है? Because the 1s orbital का equation is an exponential equation. कभी टाइम रहा तो हम वो भी करेंगे. That's why you get a plot like this. As you're moving away, the possibility to find the electron is keeps on decreasing. What do you think, people, the value over here?
Tends to 0.
Last class किया था हमने. What was this? 0.529 angstrom. With me till here? But when I plot the same for 2s, what is the difference between number of nodes in 1s and 2s? 2s में if I try to find the number of nodes, how many radial nodes are there? वापस से formula, n minus l minus 1. How much is n over here? Which means there's one node. इसका मतलब if you look at this part, ये हमारा node का region था. ये जो red में किया है. Do you people remember that? Which means the possibility to find electrons over there becomes 0. So if I plot this is R psi versus R. The plot goes like that. If it is becoming 0, which means यहाँ पे हमको क्या मिला है? There is a node present. Second, if you observe, the value of psi becomes negative. That was the reason हमने psi square किया है. The reason you square the amplitude of the wave is because certain values, when Schrodinger's equation was solved, हमको negative मिलता है. इसलिए when you square this, the square of a negative number is positive. वो plot ऊपर आ जाएगा. अभी स्क्वायर करते हैं. साई स्क्वायर वर्सेस आर और आर स्क्वायर वर्सेस आर. प्लॉट दिस. यहां पे व्हाट हैपेंस फ्रॉम हियर, थोड़ा सा प्लॉट को और नजदीक बना देना, बिकॉज जस्ट यू आर स्क्वायरिंग इट. You will get that. But what will happen here? The plot becomes 0 because you have reached a node, and why does it increase again? In the red region there are no electrons. When you move from that to the 2s subshell, again यहाँ पे अंदर क्या है? And that is why plot again increases. Then again when you start moving away, the plot starts to drop. Did you will get that? Yes or no? Now if I want to plot the same for 3s, how will the plot look like? I repeat, I want to plot this for 3s. How will the plot look like? Anyone?
There will be 2 nodes. It will decrease.
How many nodes are there? Yes, in 3s, 2 nodes, which means the wave function psi will cross this line how many times? 2 times. This is 1, 2. Why 2 times over here and why only 1? Because the number of nodes in 2s. How many nodes are there in 2s? 1. But how many nodes are there in 3s? So ये भी एक node है और ये भी क्या है एक, both are nodes. When you square the plot, how will the plot look like when you square the plot? And again there's a possibility to find the electron. As you move again you find a node. Did you people get that? If I want to plot for 4s, you get the idea. Did you people get that? Yahan tak any questions in any one of the plots? Then what are we doing next? Probability density function 4 pi square r square dr psi and r. इसको प्लॉट करेंगे तो what the difference is, यहाँ पे फंक्शन के साथ ये मल्टीप्लाइंग इट विथ r square of the radius. So let's observe the difference यहाँ पे. First plot के लिए it looks something like this. Probability to find the electron पहले increases and then it, as you start moving away, it starts decreasing. This point over here, ये point is actually 0.529 angstrom. When you plot it for 2s, it looks something like this. Plot it for 3s. Now why are the peaks rising over here? Because you're doing square of the radius. The third shell का radius is obviously the maximum. इसलिए वो peak बढ़ते जा रहे हैं. And यहाँ पे peak छोटे होते जा रहे हैं. Please understand the difference between the two. I repeat, the peaks here are increasing because you multiply it with r square. Peaks increase in size, I repeat, because you're multiplying with the square of the radius. Hence they go on increasing. Did you will understand the plot for 1s, 2s and 3s? Chalo, jaldi copy this for me. Okay, students, in case you wanted to know the derivation, how you get the 4 pi r square, okay, we've done the derivation over here. Now let's continue the plots. So this was the plot for 1s, 2s and 3s. Now let's draw the plot for 2p, 3p and 4p. Let's start. Can someone tell me the number of radial nodes in 2p? Calculate करते हैं. What is the formula for radial nodes? n minus l minus 1. तो ये कितना हो जाएगा? 2 minus 1 minus 1. So number of radial nodes in 2p is 0. Number of radial nodes in 3p 1. Calculate करते हैं चलो. 3 minus 1 minus 1. And similarly 4p के लिए आप करेंगे. So the number of radial nodes would be 4 minus 1 minus 1. Number of radial nodes will be 2. What is the shape of the p subshell?
Dumbbell.
It is dumbbell. And where is the probability to find the electron? the probability to find the electron is away from the nucleus. बराबर? So यहाँ पे highest probability to find the electron is somewhere over here. अभी plot में difference समझते हैं. When we did 1s, 2s and 3s, in 1s the probability to find the electron was closest near the nucleus, and as you move away from the nucleus, what happens to the probability to find the electron? The probability decreases. But यहाँ का plot उल्टा है. What happens in case of p subshell, people? As you move away from the nucleus, the probability to find the electron increases. Did you people get that? But what will happen in case of 3p when there is a radial node? यहाँ पे एक node है. How will the plot look? The probability to find the electron first increases as you move away from the nucleus. Then what happens in the nodal region? No electrons. Then again, यहाँ पे the probability to find the electron increases. Then you reach a node, and then it again. With me? What happens in the case of 4p? How many times will it touch the radial axis? Distance from the nucleus, well, it will touch 2 times. What will you call this point as? We'll call this as a node. Square this for psi square. क्या होगा वो? This doesn't really change much. But यहाँ पे one node, how many peaks? 2 nodes, how many peaks? वो एक्चुअली हम यहाँ पे भी ऑब्जर्व कर सकते हैं. How many nodes? 2 nodes, 3 peaks. 1 node, 2 peak. And finally 4 pi r square, but 2p it's not going to change because there is no node. But what about 3p? Remember, since the distance is increasing, r square increases. How will the plot look like in case of 4p? How many nodes are going to be over there? 2 nodes. Did you will get that? That's the plot for 2p, 3p and 4p का I want you to draw the plot. ठीक है? चलो जल्दी जल्दी complete this for me. Okay, now 2p का plot, the same plot is for 3D. Same plot is for 4f and the same plot is for 5G. ठीक है? So इसमें we need to do extra for them? No. Just remember कि यही same plots for them. Similarly 3p, then 4D, 5f, 6G. You get the idea. Exactly the same plots. And last, ये plot था for 4p, then 5d, 6f and 7g. Did you people get that? ठीक है? चलो. We stop here for the day. That completes all the radial probability density plots. You can consider this as a homework question. Solve this at home. That completes atomic structure.
So,